This is the Building Automation Monthly Podcast with Phil Zito, episode 96. Hey folks, Phil Zito here, and welcome to episode 96 of the Building Automation Monthly Podcast. And in this episode, I'll be talking through 7 tips for improving as a BAS professional. So let's dive in. So tip number 1 is to learn the processes. Now, one of the things about building automation systems, and especially if you're a technical oriented person, is that BAS is not as much about knowledge as it is about processes. And this is one of the things I see a lot of folks struggle with. It's this kind of feeling of, oh, if I could just learn a little bit more, I'd be better. Well, you definitely need to learn more, but it's not learning more facts. It's not learning more knowledge. It's learning more processes. And that's kind of the big difference. Whereas when you're a mechanic or when you're an electrician, there's a lot of facts. Now, don't get me wrong, there's a lot of processes you need to know in those trades as well. But there's definitely a lot of facts you need to know, a lot of things you need to know. Whereas with building automation, it's pretty simple as far as the facts go, right? You've got inputs, and then you use some sort of control mode, and that modifies an output. And that's your big fact that you need to know. I feel like if more folks knew that about building automation, then we would see a lot better installations. But what you really need to understand is processes. So let's take a look at what that actually means so that you can kind of wrap your head around this. So, for example, installing a VAV controller. On the surface, a VAV system is very simple, right? It varies airflow, varies air volume. Well, when you're installing a VAV controller, you could find a lot of different ways to do this. But in general practice, you go and you set the damper actuator to closed. You put the VMA or the VAV controller or actuator on the damper shaft. You mount it on there. You connect power. You connect your sensor. You connect your airflow, and then you check your system. You check your inputs. You make sure that you can drive your actuator output. And that's a process, right? But then imagine how someone who is really new to this, and this is one of the most common tasks that people new to a building automation career are asked to do. So maybe they go and they install the sensors first, but then they realize after they mount the actuator or mount the controller that, oh, they don't have enough wire for the sensors. So now they do a butt splice on the sensors, and now you've got this kind of hodgepodge installation. Or maybe they go and before they install the controller, they go and they mount a transformer, and they buy maybe a 20 VA transformer, and they hook this transformer up, and they don't really understand what they're installing, so they don't know about the draw that's required from the transformer, so they undersize. I mean, there's a variety of different things that could go wrong. That's why you have to have a process. So from start to finish, with everything you do in building automation, it's processes upon processes. So another common example that a lot of folks tend to struggle, and this I've noticed in building automation, that there's kind of these, what do I call them? I guess I would call them gateways that from one part of a career to another part of career, this is what kind of separates your progress. And the first is kind of understanding the fundamentals. Like, what is a building automation system? What are the parts and pieces? But folks don't usually stay in that area very long, right? They don't usually stay kind of stuck in the fundamentals. If they do, they tend to wash out of the building automation career field. I mean, that's just the reality. If they're not wrapping their heads around, this is a sensor, this is a supervisory device, this is a field controller, either they've had a crappy teacher or they're just not wired to understand building automation. And it's really important that you figure that out pretty fast. But let's say that fundamental skill is there. And I would say for 95% of the population, they can gain that fundamental skill if they're passionate about it. So then you have kind of these barriers. The first one we talked about is basic controller installation, understanding how projects run, right? But that takes you as a technician. That's an entry-level technician. That's an installer. Let's say you want to go up to that next level, which is you want to be that guy or gal who programs. Well, this tends to be another barrier. And I think a lot of folks struggle with how do I program a BAS. I'm not going to teach you that in this episode. We'll have a future episode about that. But they struggle with wrapping their mind around how do I program a BAS. And assuming you have the understanding of control sequences, which we'll talk about a little bit later in this episode, assuming that knowledge is there, then it's really just about another process, right? So you go and you put your inputs and outputs on your wire sheet, on your programming, and then you go and you pick the right logic blocks and you use design patterns. That's probably a term you've never heard someone mention to you. And that's something that, I'm a firm believer of taking what other industries do and making it work for me. And that's something that I've found quite personally has helped me a ton. I can program almost anything, and it's not because I'm some amazing, super skilled programmer. It's because what I've done over the years is I've looked at other programs and I've noticed the patterns. Like if you want to use a lead lag strategy, well then you've got a flip-flop, you've got an and some OR gates, and if you put them in a specific pattern with a timer, then you create lead lag logic. And when you really get into it, there's only a couple ways you can program that. The same with state-based programming control. You use a mux block, that's a multiplexer block, to switch between states and then turn different PID loops on and off. And you start to learn these patterns. And this is something, for those of you who are in the field right now, I really recommend that you go and you think about this. Think about the programs you're writing. Are there patterns? So for example, a simple VAV controller, I don't want you to just sit there and think, oh, this is just a simple VAV controller. I want you to sit there and think, is there a pattern to this program? Is there a cooling mode? Is there a heating mode? Is there, an occupied mode, an unoccupied mode? And think about these modes, think about how the programming works. And then what I want you to do is, whether you do this through screenshots, whether you do this through the snipping tool, whether you do this on a piece of paper, I don't care. But the fact is, I want you to start jotting down these design patterns. I want you to say, ooh, that's a cool lead lag sequence. I'm going to copy that. Because here's the deal. Once you do that, what's going to happen is you're going to have snippets of these different programs. And then no matter what manufacturer's control system you're working on, and this is kind of what was able to really help me just blow up my career, because folks were like, Phil, how can you work on all these different control systems? And I was like, well, what I do is I don't look at them as different control systems. I look at them as basically the same control system, just maybe a little different user interface. And it's that tiny shift. So I know we're going down a rat hole here, but I promise you that this ties to tip number one. Trust me on that. So you make these kind of snippets of code, right? And then what happens is when you go to another controller, whether it's, Johnson, Siemens, whatever, you can go and then say, okay, well, they may not call it a mux block. They may call it a state block or whatever. It doesn't matter. As soon as I learn what the block is called, I can write that exact same program in that other manufacturer's programming software. And it's really cool when this clicks, because, oh my goodness, do your bosses love if you are the guy or gal who can go work on other manufacturers' stuff. That is like music to their ears, because that opens a whole new door of opportunities to them. But what does this have to do with processes? Well, if you don't make a process to say, hey, whenever I see a program, at least if you do this for 2 months, for the next 2 months, every time you see a program, look for the patterns. Is there a lead lag pattern? Is there a economizer pattern? Is there a state-based pattern? Is there an alarming startup pattern? Maybe you're watching for a damper end status to make and go into a negated and input, and based on that, with maybe a 30-second on delay timer, or maybe it'd be an off delay timer. I'm trying to visualize this in my head. But you do a timer into an AND gate and you negate that input, and if it doesn't make, then there you go. It shuts off this AND gate and turns off the fan. And you can do it a variety of ways, but essentially what you're doing is you're going and linking out these common patterns. All right. So tip number 1, learn the processes, document the processes. As soon as you figure out the processes, you will see a massive increase in your career. Tip number 2, get comfortable with the front end. Here's a reality that folks don't want to tell you. And some of you're going to hear this and you're going to think that I'm just being an ass. And I'm not trying to be. And I'm not thinking I'm better than anyone. So I just want to preface that because I know I'm not. But here's the reality. I can find 10 installers for every one person who can work on the front end. That's just the reality. I had some guys work for me in the past, and they were awesome guys. I mean, they came in every morning. They were hungry to learn. And then I was told by corporate that I had to let some people go. And the fact is I had to let the guys who were installers go because I could always go find more installers. I couldn't find more folks who could do the front end. That was hard to find. And so if you're able to go and figure out this front end thing, which I mean, ultimately, right? I've talked about this in the past. A building automation system is the visualization and user interface layer that sits on top of a control system. So building automation is not the field controllers. Those are part of it. But really, building automation is the front end. It's the database. It's the reporting. It's the trends. It's the alarms. That is building automation. And the sooner you wrap your head around that, and the sooner you start focusing on that, the sooner you start seeing a higher return on all the work you do, and you start seeing a higher salary and virtually limitless job options. Because here's the deal. You got to start thinking like a business person, like a manager. And I know you probably don't want to hear that. A lot of us, I used to be this way too. I'm a tech, man. I don't want to know that finance crap. I mean, I'm a tech. But here's the deal. I'm not telling you need to become an accountant, but you should at least understand how profit is made, because here's the deal. You've got revenue minus costs equals profit. If you generate more profit than everyone else on your team, guess who's not going to get fired? I mean, all things being considered, I mean, the reality is, sometimes people have favorites and things like that, but all things being considered, all things being equal, the person who makes the most profit is going to have ideally the most salary and ideally be the most utilized and most valued person on the team. So how do you make the most profit? Well, you do work that your boss can charge a lot of money for and thus make more profit, because salaries are usually going to stay the same. Billable rates are usually going to stay the same. So now when you start going and executing higher end work, you need someone to come in and redo your user interface, do database backups, do graphics, do reporting, analytics. That all has a higher perceived value by the customer and by the person who's paying you than someone going and installing a sensor. Right, wrong, or indifferent, that has a higher perceived value. Well, since that has a higher perceived value, that's where you want to focus. So you need to get very comfortable with that. So how do you get comfortable with that, right? How do you get comfortable with a front end? Well, the first thing you can do is you can go home to your house. You can go on Microsoft. I think you type into Google, and I'll link to this in the show notes, Microsoft Evaluation Center, and download a version of Server 2016, I believe it is. and get a copy of your building automation server software, install the server software, maybe even take it a step further, go get a VirtualBox VM or spend the $99 to buy, what is it? VMware Fusion? No, it's not Fusion. I'll link to this as well in the show notes. But buy VirtualBox, which is free virtual software, or VMware, which is paid, but it's not terribly expensive. And you go and you buy that, you get your free version of Server 2016, which you can have for 6 months, I believe. 180 days, actually, so 3 months. Yeah, no, 6 months. It's 4 o'clock in the morning when I'm recording this, so I'm trying to do math here. All right, so you do that, right? You go and you get your virtual machine, you get your server OS, and you install that. You install your server OS on a virtual machine, and then you install your BAS software on that. You mess with your BAS software, do backups, do uploads, do downloads, do trend reports, do reporting. Try to go into the database. Go and Google, or actually I wrote an article on SQL queries. I'll link to it in the show notes. Go and do SQL queries. Do all these different things and get very comfortable. And I think you'll see if you're willing to put in the hard work for a couple weeks, you'll start to get very, very comfortable with the front end, which getting comfortable with the front end is going to also completely change your career, because now you will be the guy or gal who goes on the job site and doesn't need someone else to be there holding your hand. You'll be able to go do backups, you'll be able to do uploads, you'll be able to do graphics, and that all immediately separates you from your peers. So the third tip you want to focus on is control sequences to programs. Now, in tip number 1, I talked about processes, right? I talked about how it's very important in this job to understand and create processes for yourself. So one of the biggest changes you can make to your career is to learn how to interpret control sequences. And so this is something that I'm going to cover in great detail in my upcoming course, Control Sequence Fundamentals. And I encourage you, if this control sequences and how stuff works, if that's something you don't understand, I really encourage you to check that course out when it releases late January. But in the meantime, here's kind of that whole thing in a nutshell, right? As I've said again and again and again, at the end of the day, building automation, it's all about processing inputs, choosing the right control mode, and then driving an output based on the output of that control mode. And as soon as that clicks, things just, it's like I said before, it's like Neo in the Matrix, where he's looking and then everything turns to binary code and he starts being able to do crazy backflips and dodge rolls and all sorts of stuff. So how do you do this? How do you go and gain kind of this capability? And what does this capability even look like? Well, here's the deal. Whenever you do an install, you're typically going to get what's called a sequence of operations. And some sequences are going to be awesome. They're going to be clearly defined. Other sequences are going to be a couple sentences. So let's kind of start with middle of the road. You get basically this chunk of text. It's maybe 2-3 pages. And what it allows you to do, and I've actually got one right here, so it's like a VAV reheat. And I'm not going to read this whole thing to you because that'd be boring as heck. But essentially, this is for electric reheat variable air volume box. And it says, a zone sensor is going to transmit zone temp and then zone set point information to the VAV controller. And then the controller is going to modulate the damper in order to provide cool air. And as the temperature falls towards that point, the damper is going to be modulated towards its minimum position. Okay, so right there, you've heard a lot of information. So I want you to think in your head, and if that means you need to pause the podcast to do that, that's totally cool. But I want you to think about, what is the input here? What am I controlling to? What is my output? And then what is my kind of set point, and then what control mode would I use? And I've talked about control modes in the past, and I go through that in great detail in my Building Automation Fundamentals course. So if you don't know that, I encourage you to take that. But I want you to think through, what is the input, what is the output, and then what am I going to do? So when I look at this, I say, okay, there's a zone temperature and a zone temperature set point. And I see that I want to drive my damper in order to control to that set point. I also see that there's something really sneaky in here, and it says that there's cool air. Now, if you were just simply looking at this, right, you could be very tempted to say, okay, I'm going to write a program that looks at zone temperature and zone temperature set point. That's going to go into my PID loop, and then my output is going to go to my damper. And that would be absolutely 100% wrong. And here's why. Because you're missing the value inside the value. And so whenever you're processing a sequence, you really want to look for all the things that could be controlled. And it's in that second sentence that I read that we see that there's actually another value that we're controlling, and that is the amount of cool air. So what's actually happening, and to make a long story short, essentially with VAV control, what you do is you look at your input and output. That goes into a PID loop that gives you a 0 to 100% signal. And then that 0 to 100% signal comes out, and that goes into basically what's called a scalar object. And that scalar object has a high, which would be 100%, and then 100% would correspond to your max cooling CFM. And then 0% would correspond to your minimum cooling CFM. So what's going to happen is you're going to have an input, your zone temperatures, and then you're going to have your set point, zone temperature set point, that goes into a PID loop, and that PID loop gives you an output, and that output's a 0 to 100% signal, which goes into a scalar. And that scalar object is then going to say, okay, I'm going to go and I am going to scale my CFM set point. Now, that CFM set point is going to go into another PID loop, and that PID loop is going to go and look at CFM as the input and look at that calculated CFM set point as the process variable, or not process variable, as the set point, and then the output of that is going to drive the actuator. It's going to drive the damper. So do you see kind of what happened there? Are you following what I did right there? What I did right there was I looked at this sequence and I started to pick it apart. And that's kind of one of the things I want you to get comfortable with doing, is starting to pick apart control sequences and convert them into programs. Now, when you get really good at this, what you'll start to be able to do is you'll start to see wording in sequences, because there's only so many ways you can control a piece of HVAC equipment. Now, you'll start to see kind of patterns. And when I see that pattern of zone temperature control to damper actuator, via the airflow, I know that there's a pattern of two PID loops, a scalar object, and an input and an output, right? I know that pattern because I've done it so many times. And as you start to see this, that is how you're going to do programming. And I think this will take a lot of pressure off of you, because I meet a lot of folks who are new to building automation, or they've been in building automation or HVAC for a while, and they're trying to take it up to the next level, and they just feel very overwhelmed by the idea of writing a program. It seems like, and I get that. I remember the first time I went into Allerton. I started with Allerton, and you wrote your programs in Visio, and you used what was called Visual Logic. And I feel like, thanks to Allerton is kind of why I learned to program, because when I went to Johnson Controls, which was where I was at before I resigned my position to teach full-time at Building Automation Monthly, I realized how spoiled I am, or was, because at Allerton it was Visio, it was Visual Logic, at least back when I was there. And it was literally, I had my stencil blocks, and I had to go and drag and drop those stencil blocks and build programs from scratch. Yeah, sure, they did provide some template programs. But I was told, and in my ignorance, I did this. I was told, no, you never use template programs. You got to do it this way. But that's a whole nother story. And then I get over to Johnson and they have CCT and it's a question and answer. And I basically tell them what the mechanical system is and it writes the program for me. And I'm like, oh my goodness, this is so easy. But the thing is by doing that, I knew the design patterns. And so when I started running into these really crazy sequences that no one could seem to figure out, I was able to do that because of what I just walked you through. So tip number 3 is learning how to take sequences of operations, control sequences, and turn them into programs. And this is something you can as well practice. You can go on Google and you could type in building automation sequence of operations, file type : DOC or PDF, and that will give you a ton of different control sequences. And then you can actually go into your programming software and you can try to write those sequences. And you can try to start seeing the patterns. Okay? Alrighty. Now on to tip number 4. Pick a troubleshooting method and only one troubleshooting method. Now, I hear quite often this saying used, and I don't agree with it. I think it's absolutely wrong. I hear there's installation techs and there's service techs, and you can only be one. And I think that is a bunch of BS. And I've also heard, well, you can only work service if you've worked install because I don't want someone who doesn't understand what they're doing. Service, to me, first off, I think everyone should do time as a service tech because it's awesome. You get exposed to some crazy stuff. And I feel like you get exposed to a lot of things that aren't perfect. So it improves your ability to install because you're like, man, I saw the ball of crap that guy was left with. I don't want to do that. But I think it also exposes you to a bunch of different things in the shortest amount of time. So I really count a lot of my success to being a service tech very early in my career. But like I said, I don't think that you're a service tech or an install tech. Once again, I really think it comes down to processes and just having the right processes. And one of the processes is a troubleshooting method. And this is really important. See, I see folks and they start troubleshooting, and let's say they start with the bottom-up method, which is personally my favorite method. It's the slower of the two methods I'm going to cover today. But personally, I see the best results from it because you tend to not miss stuff. Well, you start with the bottom up. Let's say you get a room is hot call. And you go to the VAV box, and bottom up would say, okay, first I check the inputs and the outputs. Is my sensor accurate? Is my airflow accurate? Is my damper actuator actually driving and open? And then from there, you would go and say, okay, well, are the balancing dampers open or shut? Are there any fire dampers? You work your way from the bottom up. But what often happens, especially with newer folks who don't follow a method, they go and they check the zone temp and they check the airflow. And maybe then they're like, ooh, I don't have any airflow. I'm going to go look at the air handler. And then they go to the air handler and they start looking at the air handler. And then they're like, yeah, but maybe it's chiller. And then they go to the chiller. And then before you know it, they have been all over this building and it was a closed fire damper. Whereas if they simply went from the bottom up, they would have seen that, oh, well, I've completely checked the VAV box. What's next in line according to the mechanical drawing? Oh, there's a balancing damper. Okay, because you're literally following the mechanical ductwork on the drawing, pending that the drawing's actually accurate, but that's a whole nother topic. So you're following the mechanical ductwork, you hit that balancing damper, you're like, oh, the balancing damper is fully open, or whatever it's supposed to be, that's good. Oh, the fire damper's closed. Oh, well, that's not good. And then you go and you take care of that. And, you know, I'm just using examples here. You may not have a fire damper in line. You may actually have that sitting in the plenum or whatever. But the point is that you just follow the system from bottom to top. And then there's also top down, which is another method. It is much faster, in my opinion, if you have the experience to immediately go to the right area. And what I mean by that is top down does not mean you start at the trend logs and then you go to the server graphic and then you go to the supervisory device and then no. Top down means, all right, based on what I think here, I'm going to check the air handler. And then, the air handler's good, air flowing, and then you work your way down. So pick one troubleshooting method and stick with that one troubleshooting method. And I think you'll see a much easier time troubleshooting building automation systems. So tip number 5, and this is going to be a hard one for some of you to accept, and I'm cool with that, but you need to realize you're not an engineer, you're not a mechanic, you're not an electrician. You are a building automation professional. Now, I know some of you have been electricians in the past, some of you have been mechanics in the past, some of you have been IT folks in the past. But here's the reality. You're not being paid to be an electrician. You're not being paid to be a mechanic or an IT person. All right? You are being paid to be a building automation controls professional. So I see so many techs get talked into doing out of scope work. I'm not getting enough power. Well, can you help me check the contactors or the transformer? And it's like, no, I'm not going to check the fan contactors because that's not my responsibility. And I know this goes against everything you're kind of wired to do. You want to solve the problem. You want to fix things. But at the end of the day, that's not your job. And then you start doing stuff like that. And before you know it, you've spent, 6 hours troubleshooting a VFD when really the VFD, the only thing you need to be concerned about is the input, output, the safety, and then your speed command. And if those things are working, then find the person who did startup on the VFD and go from there. I know you're like, but Phil, I can just log right in and check. Yeah, you could, but you replicate that times 100, and that's, almost 1,000 hours if you spend 10 hours. No, that's a bad example. Let's say it'd be 200 hours if you're spending 2 hours on a VFD kind of just troubleshooting things, and you do that across a year. And yeah, that's a worst case scenario, but you can start to see how if you focus on stuff that isn't controls, you're going to be inefficient, you're going to get distracted from what you need to get done, and things just aren't going to go well for you. So don't focus on fixing the IT network. Don't focus on going and doing startup on the equipment. Don't focus on troubleshooting contactors and distribution panels. Don't focus on redoing the sequence of operations. Focus on doing the controls. Just do that. Just focus on doing the best controls program, install, graphics, setup that you can do, and then go from there. And you will have a much easier life. Now, here's one that I don't see a lot of folks do, and I don't know why they don't do it. And that is tip number 6. Read the spec and drawings on every job you get. And, saying I don't know why they do it, that's probably not the most accurate statement. I should preface that with saying I know why they're not doing it. I mean, you get a spec and you get a drawing and you see a VAV sequence and you're like, I've done so many VAVs, I don't need to reread that. Until you realize after the fact that maybe they're doing some sort of zone averaging and they've got one zone temperature sensor for 4 VAV controllers. Yes, I've seen that before. I don't know why folks would value engineer a system like that. That's stupid as all get out. But that's what they did. And so you got to start going and reading the spec and drawings on every single project you get. That's something you really, really want to hone in on and make sure that you're paying attention to, because that will go and save you so much time and headache. And there's not any particular one way to do it, although I've found a way that tends to work for me, and I cover this in my design fundamentals course, but I'm going to give you kind of the flyby here. And essentially what I do is I read through the sequence of operations during the sales to operations handoff, and you should be doing that before every project you take on. And if you're going and doing a retrofit opportunity, well, then you're doing a service call, you may not have a sales to operations handoff. Totally get that. But if you do, understand the scope, right? And then from there, go and get a copy of the specification and the sequence of operations that's within that spec, as well as the mechanical drawings. Take a look at all of that and read through and start to take notes. Highlight kind of the areas that you have questions about or the areas that just don't make sense. And that's what the RFI, RFC process, request for information, request for clarification process is, at least on projects. And if it doesn't make sense to you and you're on a service call or a retrofit, just phone a friend, find someone you can reach out to and ask them to help you make sense of it. But just make sure you go through before you start doing stuff, because that's a huge area that you should not be making mistakes on because you didn't read the sequence, you didn't read the drawings, you didn't read the plans. Even after my career, and some folks I've known who've been in twice as long as me, they still go and look at the specs and drawings on every job because we're professionals here, right? And that's what we do. And tip number 7, and this one is, this is a huge one, and it's learn how to spot opportunities. You should never be in a position where you're going and getting sent home because there's not enough work. And yeah, you can hem and haw and say the salespeople aren't selling and, the market's slow and da-da-da-da-da. But, back in 2008, when no one was spending money, I was out there finding $200,000, $300,000 controls retrofits. Fact is, people always have money. They just don't necessarily have money for you. And as a technician or a technical professional, you're in a great spot to be able to upsell and change order and be able to generate more work. And, I don't mean this to sound in a negative way. I know a lot of folks hear the word change order or upsell and they feel like that, well, if the system was designed right, we wouldn't have to do a change order. Or, I'm just gouging someone by upselling them. That's something they should have by default. Well, for example, you go on a service call and there's multiple systems in alarm and you realize that all of the alarms were all set up with the exact same priority level and they've got, 50,000 unacknowledged alarms. They just hit Control and A and select all the alarms and delete them twice a day. Well, that kind of defeats the whole purpose of alarming, right? So in this case, you go and you upsell an alarm reconfiguration. You help them create an alarm standard and apply that alarm standard. You've created a week or two worth of work for you. You've put the customer in a much better position now that they're actually able to know what alarms they should react to. Maybe you even help them develop some processes around responding to those alarms. That's just a simple Word document. And now you've made them much more self-efficient. You've created work for yourself, and the customer is going to be ultimately happier. Maybe you go to a site where the controls are just completely out of whack. It's been folks trying to tinker with them for a while, and you go and just offer them, hey, you know what? I can come and reprogram your controls, and we can do a retro commissioning, and we can just reset everything from scratch and check that out. You'd be surprised how many people are actually willing to do this, because think about it from the customer's perspective. The other option, and the option they're told quite often is, oh, your controls don't work, you need a new control system. Well, no one wants to go and buy a new control system. But if you tell them, hey, you could keep your existing control system and we could just do some reprogramming, that is a very attractive offer. And that's something that, at least back when I was a service tech, I was able to upsell those every day. Well, not maybe every day, but at least once a month, because there's a lot of bad programming out there. And once again, you're not trying to go and create work that doesn't provide value to the customer. You're going and finding value first kind of work. I'm going to help you do something that is going to ultimately save you a lot more money. And then finally, another kind of option is optimization. There's so many systems that aren't optimized. They're not using resets. Their schedules are 24/7. I mean, these are things that you could go and offer, 2 hours a month to come out and just work on optimizing their systems. And this would be something that the return on them spending money for 2 hours of your time. I mean, think about it. If they're running systems 24/7, or they've got no discharge air resets, or they're not using economizer and free cooling, what is the return on the time they're spending for you? I mean, it's massive return, and it easily pays for themselves. Now, I could go into, learn the energy calculations and learn all those things so you can even prove the return. But in most cases, most folks understand that, hey, if something's running 24/7, it's probably not that efficient. And if I'm able to spend an hour paying you, $140, $180 an hour to go and do some reprogramming for me that ultimately makes my building last an extra year because equipment's not running, makes things run much more efficient, then I would do that all day. So there's the thing, folks. Those are 7 tips that if you apply these tips in your career, you'll see massive success. You'll see really big improvement in how your building automation career goes. So tip number 1 is to learn the processes. Building automation systems is all about processes, and the sooner you learn the processes, the better. Number 2 is getting comfortable with the front end. And that is really where the money's made. That's where you're going to separate yourself from your peers. Number 3 is control sequences to programs, going and taking a control sequence and turning it into a program using things like design patterns. Number 4 is picking a troubleshooting method, and only one, because that is really important. 5 being realizing that you are a BAS professional, not something else, so spending your time focused on the right things. 6, reading the spec and drawings on every job you get. I don't think I need to say anything more about that. And number 7 is learning how to spot opportunities, being able to go and understand where you could potentially provide more value to your customer. Now, all of this is going to be available to you at buildingautomationmonthly.com/96. Once again, that is buildingautomationmonthly.com/96. That's where I will have the show notes and the timestamps and links to the things I discussed in this episode. Speaking of things I discussed in this episode, depending on when you're listening to this episode, it goes live on December 25th. So consider this your Christmas present. In January, specifically January 1st, Building Automation Monthly Premium will be opening up again for a week. It opens up every 3 months, and each time it closes down, the price increases. And Building Automation Monthly is my mentoring program. And what it is you go and for a year, you work with me as part of a group. And as part of this, you get access to all my courses during that year, and you get accesses to calls as part of a group every other week where we're able to discuss your building automation career. On top of that, I have special subject matter expert interviews and special teachings and a dedicated forum that you're able to access. What you will get out of this is massive growth in your building automation career. This is like pouring gasoline on your building automation career. It's going to turn it into an inferno, help you really light things up, and really take your building automation career to the next level. So if you're in sales, or if you're a technician or an operator, this program is great. I've got folks who are in sales, folks who are facility operators, as well as folks who are technicians and managers who are part of this program, and they're seeing great results. So I really encourage you to check that out when it becomes available. Now, how will you know when it becomes available? You'll know because if you're a part of my email list, you'll get an email about it. So that's one of the reasons why you want to sign up for my email list. But also, I will be making an announcement both on LinkedIn and on Facebook and on my site about BAM Premium being open. So I encourage you to check that out once it's available, because it'll only be open for 7 days and then it'll close back down. With that being said, I hope all of you who are listening to this on or after Christmas have or had a great Christmas, have an awesome new year. Apply these tips, and I look forward to hearing back from you about how much your building automation career has improved. Thanks so much for listening. We're almost to episode 100. That is just absolutely crazy to me. And I've got a lot of really cool stuff coming up for you in 2018. A lot of expert interviews and a lot of more technical kind of process and procedure related podcasts like this coming down the road. So thanks so much for being here, and I'll talk to you again next week. Take care.